Bismillahirrahmanirrahim. Assalamu alaikum. Okay, let's continue with sets. And the first topic we will try to understand is subsets. Okay, when we talk about subsets, they are of two types: proper and improper. Okay, to understand this concept, let's take an example. I'm going to take a set and a subset, and then we'll talk about this concept. Okay, A is a set -2, -1, 0, 1, 2. So it's a set of integers from -2 to 2. Okay, now B is 1 and 2. It's a subset. Now, why A is a set? So, we have taken it. It's our supposition that this is a set. Now, it's a subset. So, why B is a subset? B is a subset because it contains two elements, and those two elements are also in set A. Okay? So, and it is also a proper subset. So it means that the definition of the proper subset is that if it contains the elements which are also in the set, but it does not contain all the elements of the set, right? So the subset contains some elements of the set, but not all, okay? If it is a situation that the subset contains some elements but not all elements of the set, then it is known as a proper subset. Okay, so it's an example of a proper subset. Okay, so now let's represent this through a Venn diagram. Okay, this is A -2, -1, 0, 1, 2. Okay, so, and this is B. Okay, so A is a set, B is a subset, B contains some elements of A, so that is why it is a proper subset, right? And we also write it as A contains B. A contains B, so B is a subset of A, right? Let's take another example. Now C is also a subset, and C is a proper subset of A, right? Why it is proper subset of A? Because it contains only one element, and that element is in A, and so it is also a proper subset. So now here we can say it like this. So this is our C. Okay, C is a subset. There is another subset, a proper subset of any set, which is a null set. So null set is like or 5. It is a proper subset of any set. Okay. Now, so this was all about proper. So then what is an improper subset? If any subset contains all the elements of the set, then it is an improper subset. Now, supposedly, if D is equal to -2, -1, 0, 1, 2. So D is a subset of improper subset of A because it contains all the elements of A. Now we can say A contains D, or we can say D contains A, because both have the same elements. So both the sets are subset of each other. Okay. So this was briefly about the subsets. Now let's take an example of a union of sets. Okay, now we are going to discuss union of sets. So what is union of set? It is basically a collection of elements of both the sets. If we have two sets, then the union of set will be collection of all those elements which are in those two sets. Supposedly, if I have A is equal to 1, 2, 3 and B is a set which is, let's say, 3 and 4, then its union is going to be all the elements in both the sets. Now let's represent this with the help of a Venn diagram. So now this is our two sets A and B, and of course the rectangle is representing the universal. Now why I have drawn overlapping circles? Because I can see here there is an element which is common to both the sets. That is why I have made the overlapping circles. Now let's place those elements over here. 1, 2, 3 and 4. You see, the 3 is common to both, so I'll place it here, and 1 and 2 is placed here, which belongs to A, and 4 it belongs to B, it is placed over here. Now the A union B, how we are representing mathematically A union B? So A, this union B. This is the way we write A union B. So it is the collection of all the elements in A set and B set. So A union B, which is very evident from this Venn diagram, whatever there is in the set A and set B, both is going to be in the union of A and B. So it is going to be 1, 2, 3 and 4. Okay. So the elements from set B and elements from set A, combinedly they have given us union A union B, and which is like this. Okay, and another concept is intersection of two sets. Now let's discuss that. Okay, now we have discussed union of sets, now intersection of sets. The example is the same. They are same two sets, same Venn diagram. Now I am going to talk about intersection. In the union, what we did was, it was collection of all the elements in both the sets, right? Now in intersection, it is only those elements which are common to both the sets, not all, okay? And mathematically it is written as A intersection B. So A intersection B is the set of all those elements which are common. So this Venn diagram, which we have already drawn, it is very clearly helping us that what is common between A and B. This is the only common thing between A and B is this number 3. So A intersection B is 3. So union gives us combination, collection of all the elements which both the sets have, and the intersection gives us commonality. Whatever is common is in the intersection of the two sets. Okay. Now let's take another example. Okay, now we are going to talk about complement of a set. We have two sets, A and B. So what will be the complement? The complement will be, complement of B is represented as B complement, Or sometimes in some books you can see it like this, it is written like this. But usually it is written like this. And complement of A is A. Now let's see what is the A complement or the B complement. So if we are talking about A complement, now A complement. So to find out the complement of A is to exclude all those elements which are in the A and take the rest whatever it is in the universal set, right? That simply subtracting a set from the universal set, and whatever is remaining is the complement. So in the set A, what we have? 1, 2, 3. So the complement will be to totally remove all the elements in this and see what is left. And if we remove all these 3 elements and see whatever is left in the universal, and in our case the only thing which is left is 4. Okay? And if we talk about B complement, it is universal set minus set B. So we have to exclude B, and the complement will contain whatever is left after subtracting set B. So we are left with 1 and 2. So the complement of B is 1 and 2, because if we remove this we are left with 1 and 2. Complement of A is, if we remove this we are left with only 4. Okay? So let's take a proper example now. Okay, we have a universal set here. X such that X is a positive integer not more than 9. A set here, X, which is a subset of a universal. X such that X is an odd number. B is also a subset of universal. X such that X is a multiple of 3. So let's first see what is in this. So it has positive integer not more than 9. Okay, so first let's so this is our universal set. Okay, now A is a odd. So 1, 3, 5, 7, 9. Okay, and B is multiple of 3s, so 3, 6 and 9. Okay, so we have all the 3 sets. Now through a Venn diagram let's try to find out all these. So a Venn diagram. Okay, so we have a Venn diagram over here. I'm going to place these numbers A and B, and then whatever will be left will be placed in this rectangle because it belongs to universal set. So for this, when I am going to place this, I'm going to check that is there anything common in both. Yeah, 3 and 9 is something which is common to both the sets, right? So 1, 3, 5, 7, 9. Okay, now 3 is already in the B, which is in the common area now. 6 and which 9 is already there, right? Now let's see. Now coming back to universal, what is left? 1, which is already there now. What is left? It is 2. So 2. Then 3 is there. 4 is not there. 4. 5 is there. 6 is there. 7 is not, 7 is there, 8 is not there, so here. Now these elements are of the universal set which are not in these two sets A and B, which are the subset of a universal set. Okay, we have placed our elements in this Venn diagram. Now let's see what is A union B. So A union B, all the elements in both the sets 1, 3, 5, 7, 9. 3, 5, 7, 9. Okay. We have this A union B now, so we have to take a complement of A union B. So we have to exclude whatever there is in the A union B, and we are going to take the remaining one. So we are going to remove A union B from the universal set, and whatever is remaining will come to A union B complement. So A union B complement. So we are going to remove this all. Whatever in these two red circles we are going to remove. What are we left with? 2, 4 and 8. 4, 8. Okay. So this is the complement of A union B. Now finally I need A complement intersection B complement. For that, let's first find what is A complement. So A complement, removing the A, I have to remove 1, 3, 5, 7, 9, and whatever is remaining comes to A complement. What is remaining after removing A? What is remaining? 6, 2, 4, 6, 8, right? 4, 6, 8. So this is our A complement. Now, the B complement. I have to remove B, so I have to remove 3, 6, 9, and whatever is remaining I am going to write over here. So which will be 1, 2, 4, 5, 7, 8. Okay. Now intersection, and for the intersection I have already told you that it's a commonality between the two sets. Now the common between A intersection and B intersection. So A intersection, A complement intersection B complement is the common between two. 2, 4, 8, these are the common elements. So 2, 4, 8. So now from here we can see this. This and this are equal. A union B complement is equal to A complement intersection B complement. So this equality is also known as a very famous De Morgan law. So we have proved there are two De Morgan laws. We have proved one of the De Morgan laws, and the same way you can prove the other one also. So this was about basics of the set. Okay, thank you.